Okay, so here we're going to look at the square root of 72. So again, I listed the perfect squares, for convenience. Now the question is this going to be simplified, the square root of 72? Well, we could list the factors of 72. We have 1, we would have 2, 3, but we know 9 is a factor of 72. How do we know that? Mostly because 72 divided by 9 is another integer. So 9 is a factor of 72. 9 is a perfect square. So even without this stuff, we would see that the square root of 72 is not simplified. We could simplify it. There's a factor of the radicand, in this case it's 72, there's a factor of it that, besides 1, that's a perfect square. And so in step 2, right, what we do, we factor. We have to divide to get what's left over, right? And then we have 72, it's 9 times 8. And so then what do? Just like before, we take square roots. Square root of a product is the product of the square roots. And we saw already the square root of 9 is 3. Square root of 9 is 3. So what we get is 3 times the square root. But now we have to ask, okay, what about the square root of 8? Is that simplified? Well, it turns out the answer is no, as you can see on this slide. And how do I know that? Well, if we listed the factors of 8, we would see 4 is a factor of 8. Right? 4 times 2 is 8. 4 is a perfect square. So because of that, the square root of 8 is not simplified. So we can simplify it. And that's what we're doing here. Right? 8 is 4 times something. How do you get the something, the 2 that is? You divide. And so from here, we take square roots. Square root of 8 is the square root of this product, which is the product of the square roots. And we know the square root of 4 is 2. So from here, we get 2 times the square root of 2. Okay, so now what do we do next? Now we plug it in over here, as you can see. And so altogether, we're going to get 3 times 2 times the square root of 2. And that's, of course, 6 times the square root of 2. Okay, let me just say this also. The square root of 2 is simplified. Really for the same reason the square root of 5 is. If you were to look at the factors of 1 and 2, of 2 itself, you would have only 1 and 2. 2 is not a perfect square. So square root of 2 is simplified. I didn't show it on the slides. Maybe I should have, I don't know. But basically, I just said it. The square root of 2 is simplified. So we're good. Okay. Okay, now some of you might be thinking, wait a minute, couldn't we have 72 equal to 36 times 2? You could do that if you want. I mean, this is not the 9 and 8. They're not the only ways. Okay, hold on. There we go. Using the fact that using 72, using 9 as a factor, right? That's not the only way to see 72 as a perfect square. There's other ones like 36. 36 is a factor of 72, and 36 is a perfect square. So you could do that. That's fine. So 72 has at least 3 factors, including 1. That's a perfect square. Okay. Just something I wanted to point out. All right. Anyway, so we get that. Okay, so that's basically with simplifying square roots. What I want to do quickly is rationalizing denominators. Then I'll post some examples right through a worksheet for people to try out. Okay, let's do that. Now, to rationalize a denominator, I wrote it on the slide. It just means you don't want any radicals in the denominator. That's all. Not just square roots, but you don't want any radicals there. So again, what we're going to focus on is only when square roots are in the denominator. And really, to eliminate it, this is a property we're going to use. And it's really not hard to see why this equation is true. It's really just from the definition of what the square root is. But if you take the square root and then you square it, you're going to get back the number itself. If the radicand here is non-negative. Okay. So using this, we can eliminate square roots from denominators. That's really what I'm trying to show here. What I'm trying to show is you're going to multiply top and bottom by the square root. And then using this property, that square root goes away. The book does this also for other radicals. They also do rationalizing the numerator, but I'm just focusing on rationalizing the denominator. Of the two, at least for this course, this is what we care about, rationalizing the denominator. So this is just one example. If you have 1 over radical 2, okay, so if we want to rationalize this, we want to get that square root of 2 out of there. How do we do that? We're going to follow this process illustrated in this equation. We're going to multiply and divide by the square root of 2. Excuse me, we're going to multiply top and bottom, that's better, by the square root of 2. So on top, you get 1 times the square root of 2, which is just the square root of 2 itself. On the bottom, we get the square root of 2 squared. From this here, we'll have 2. And so we get this. So that's really how you rationalize the denominator. Just for fun, I threw in another example here. It's the same story. Namely, 3 over radical 5, right? Again, we want to rationalize this. So we would multiply top and bottom by the square root of 5. Doing so, the denominator will become the square root of 5 squared. Using this rule again, here, we get this. And on top, we have 3 times the square root of 5. That's all. But now you can see the square root is gone. And that's good. That's what we want. Okay, let me just pause the recording.